Hello, we are Team SpaceY from the Build a CubeSat course, and this is our final event video. Our science objective was to photograph images of penguin guano in Antarctica to estimate penguin colony size and location. We had to use the guano because individual penguins are not visible from space, but their guano, or poop, is. Some requirements of our CubeSat was that we had to take clear images of the Antarctic terrain every 60 degrees. Our flight Pi had to transmit photos taken by the camera to the ground Pi at a rate of at least 36 kilobytes per second over Bluetooth. The ground station Pi had to push the images to GitHub, where team members could analyze the photos and determine area and angle of the colonies. The ADCS shall be able to indicate the location of the CubeSat in degrees with a 5-degree margin of error. This is the CAD model of our CubeSat. As you can see, our Raspberry Pi, IMU, and camera are all located on the bottom panel. The solar panel and battery are mounted to the top panel, both attached using Velcro. We ended up building our CubeSat pretty close to our CAD model, except we didn't actually end up using the solar panel because we all were in different lighting conditions, and it actually ended up raining on flight day, so we couldn't have taken our CubeSats outside. Additionally, our CubeSats were not made from space-ready materials, but were able to provide us a good enough prototype for flight day.
On flight day, we plan to use this spreadsheet to calculate the area of the penguin colonies based on the images that we took from the GitHub sent by the person's satellite who was doing the orbiting. In the telemetry packets, we got an angle between 0 and 3600, 0 to 360 being the first orbit, 360 to 720 being the second orbit, and so on. And that was the raw angle that went here. We then were able to calculate the order number it was on based on whether it's between 0 and 360, 360 and 720, and so on. The image name that we were taking the information from. The angle that our telemetry sent was the initial angle that the satellite started at. And we used that in a little bit of math to calculate the actual angle that the guano colony was at. And using that, we could find the sector it was in. And then looking at the image, people in the ground station could count the number of triangle-shaped pieces, semicircle-shaped pieces, microphone-shaped pieces, and curves, and then use the spreadsheet and a little bit of math to calculate the area of that colony.
Following snippets are pieces of the test run that we did right before the actual flight test that we did. And as you can see, even though it didn't really downlink to our ground station, it actually did take pictures. But unfortunately, that didn't really happen in the actual flight. So we weren't able to get any partial credit for any of these. But, well, it's still cool.
And here we have an official setup of the orbiter and everything else. We have a can of soup to the right to counterweight the weight of the CubeSat. And then basically on flight day, we spin the orbiter 10 times and have it take pictures, and then have it to downlink to our ground station Pi, which we can then view the images to estimate the location and area of the guanos.
We were able to get 2 images downlinked on one of the orbits of one of our 4 passes. The other 3 photos weren't even taken or downlinked because our code ran into some errors at the very beginning of its implementation. But for one of those orbits, we were able to get some information, which was better than nothing. So on that successful pass, this is the error message that we got, and also some of the success messages that we had. Basically, what this is showing is that the code that was running on the main satellite was taking images and sending them to the ground satellite, in which they were received. But when trying to push them to GitHub, add them to the folder to be viewed, there was a merging error, and it just stopped the whole code, resulting in a failure of the whole mission.
Here is a video of our ground station running normally.
The rest of the team members' images didn't downlink at all, but afterwards we were able to extract images from compressed files stored on our CubeSats in .npz format. And this is a zipped archive file, and we put it in this format to save valuable downlink time when we were downlinking our images. So after the fact, we were able to extract the images and get images of some colonies from them. And then we ran image processing code on the rounds that we were able to save to secure some more points. In testing, each team member had a successful run. However, when we put the main code in our bash RC file to run on startup, it gave us multiple errors pushing to Git, like what we saw in the round 1 results. And so we could have avoided this by doing more testing on our pies, and we did test a lot for multiple days, but so many errors kept popping up that we spent a lot of time fixing those errors and not worrying about testing them on everybody's pies. And that was something we didn't get to do until the last moment, so it would have been good if we realized that ahead of time and allocated more time to test. And another issue that we had was measuring the guano area. When we were measuring it, we likely had measurement errors, and so in order to fix that, we could have cross-referenced it better with our teammates, and everybody could have gotten their own estimate of how much area should be in each shape, and then cross-referencing with other groups might have also helped. We did cross-reference with one group, but there were still some inconsistencies after that. So, and downlinked images also happened to have some incorrect telemetry data attached. This was a error that popped up out of nowhere that we didn't really know about from earlier. It could have been fixed with further and more thorough examination of like flight day environment, like of the flight day environment. I think we could have prevented this if we had tested in the same environment as flight day, because that would have shown us like exactly what would happen. But when we were testing, we didn't always get the files to boot up on we didn't get the files to run on boot up, and we didn't have some other factors like the exact same as flight day. So it would have helped in a lot of these cases to do more testing. Despite all the struggles pre-flight day and on flight day, though, we did have a great time working together and figuring out our issues, and it was very satisfying when we got our code to run perfectly during testing. Unfortunately, that wasn't our outcome during flight day, but we had a great time on the way there.